Let's take a look at our problem of the day. Andres has 15 quarters in his pocket. If he uses 8 of them, what is the value of his remaining coins? Again, Andres has 15 quarters in his pocket. If he uses 8 of them, what is the value of his remaining coins? Let's talk about this one a little bit. This on the surface sounds like a real easy problem, and it is. I chose this for, say, first of all, we have a lot of younger viewers, and I think money is also a way that many of us who are older that forget how to do good simple arithmetic or think about making change and stuff like that. I hear that complaint a lot of times from people my age. You know, I have to make change in that restaurant. They have to put it in the cash register, blah, 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 blah. Well, you know, we're going to talk a little bit about it here. Just a little bit of some nice little shortcut methods. So I chose this problem because quarters are, I prefer to use quarters, and you can use them like going to, you know, putting money in your air to get air for the tire. There are a lot of things, other things you can put quarters in, like the parking meter and things of that nature. So they're useful. They are probably the most useful coin we have. Well, pennies are awesome, I think, too. But you get the idea. We're going to talk about it because they're each worth 25 cents. So let's think, first of all, how do you count by 25s? You know, we learn when we're growing up, we learn to count by nickels. We count by 5, 10, 15, 20, 25, 30. Let's think about quarters. 25, 50, 75, $1. Hey, all 4. Let's see. Go 4 more. $1 quarter. How about our $1.25? 125, 150, then 175. You're up to 200. So you keep clicking those 25s through there. You know, when you think about money, we really do more math than you realize in your head. But let's get back to our question here. It says, Andres has 15 quarters. So I'm going to kind of map this out here a little bit. And he is going to lose, it looks like, or he's going to spend. Sometimes you feel like when you spend, you are losing it. But you're going to have 15 quarters, and he's going to take away, how about 8 of those? And I want to end up with some sort of dollar value, okay? We'll put dollars, all right? Some sort of dollar value. Cents, maybe dollars and cents, however you want to look at it. One way to look at it, here we go. We start out with 15 quarters. We could call that, oh, this almost looks like an algebra problem, doesn't it? Well, it sort of is, all right? 15Q minus, see you folks who are out there doing money, you never thought you were doing algebra. You really are. You're doing some algebraic thinking here. Minus 8Qs. Well, how many have we got left? I think we got 7 of them. And my friends, that's one way to look at this. Oh, and you say, Ernie, I think each of those is worth 25 cents. So rather than saying 15 times 25 and 8 times 25, all I really need to worry about is what? Got 7 left over. 7 times 25. Well, let's count them up. 25, 50, 75, $1. There's 4 of them. Go 3 more. $1 quarter, $1.50, and then $1.75. So it looks to me like we have $1.75. Now, another way we could have done it, we could have written that, and by the way, some of you said, whoa, that was quick. It's simply, we counted, but you know, we could also have just simply said 7 times 25 cents, and that would also give us that $1.75. I counted them, 25, 50, 75, because for some of our younger viewers, that's easier to see. It's like a repeated addition. That's what it is. We add 25 each time. That's what we mean by multiplying 7 times 25. So, okay, 7 quarters, go out and spend some money, all right? $1.75 left over. Now, I've got one more moment because someone out there is saying, well, I bet we can make this a little bit more interesting. Well, maybe, maybe not. But let's see, what if I took 15 and I decided, let's go ahead and make those values. I could go ahead and say 15 times 25, which is quite a bit. And then I could say minus 8 times the 25. In other words, I give the values to the 15 quarters and the values to the 8 quarters, and I'm going to come up with the same solution. I think it's a little more complicated, a little bit more complicated, but I'm supposed to come up with $1.75. Let's see if it works. First of all, 15, oh my goodness, 15 times 25. We're going to have to go, let's see, 4 makes 1, 8 will make $2, 12 makes $3. We got a little bit extra, so it looks like that's going to be $3.75. For those of you who like to do the real multiplication, hit that calculator, all right? No, we're not going to go there. But we'd just be 15 times 25 cents each time. Then we're going to subtract 8. Well, remember I said 4 makes $1, 8 makes $2, so we're going to subtract $2. And look where we are. We're back at that $1.75. $1.75. So again, sometimes simple problems, there's more than one way to get to the final solution, to take care of business, to get to the final solution. That's what I want you to notice here. So here, I like it, a little kind of algebraic moment, and we just simply say 7 times 25. That was easy. Down here, we make it a little bit more, how we would say, intriguing. And you know what? For those of you who love Algebra 1, we could also say, we could take that 15q minus 8q, and we could find the common denominator, greatest common factor here, a common factor, which is q. And look what we got. We'll reverse that distributive property, and that would also give me 7q, because that gives me 7 times the q. So there are ways that we could play through this thing and still come up with, guess what, $1.75. All right, problem of the day, solved in a lot of different ways.